My name is Chris Lyon. I'm a technical sales representative for ProLon Controls, and we have some exciting information today as we are launching Focus 7.3. So this new version of Focus, we've got got a new controller that we're bringing in. We've got some other features that we've added. So in true ProLon fashion, how we continue trying to always upgrade and improve our product, we are adding to it yet again. So we're going to go through all of that today. A couple little housekeeping things. Again, please keep your microphones muted. Everybody is currently muted right now. Sophie will be managing that for us. If you do have any questions, you can send those in via chat, and we will have time to address that at the end. So let's go ahead and start into this and just see an overview of what we're looking at for 7.3. And the big announcement is that we now have a dedicated chiller controller. We have added the C1000 and M2000-CHL. So this will be a dedicated chiller controller. We've made some changes to the alerts and data logging. It should be a little bit easier to handle, to manage, see how things are grouped together. We have a new adjustable integral drop-off rate on all of our controllers that are producing a zone demand. Several just general performance enhancements to Focus. And then the other big one is that we have a completely new redesigned Android application. So let's just jump in here, starting off with that first one with our new chiller control. We've got points in here for supply and return chilled water. We have set point reset. So we can reset that, our target chilled water set point based on outside air, based on return water, based on math functions. Okay, remembering that we have the master follower communication arrangement on the ProLon networks, the chiller controller is going to be a follower controller. And so that is going to be able to talk to, say, a master that it was installed under, a rooftop per se, that we could get a math function that will represent a cooling demand, and then we can adjust our target set point out of that. This chiller controller is going to be good for both air-cooled and water-cooled chillers. So on the water-cooled side, we do have some safeties that we've integrated in there. We can monitor and do some limits off of entering and leaving condenser water. This will be good for up to 4 chiller stages and up to 2 pumps. Those pumps, of course, get status, and we can have our lead lag rotation, all that. We have pressure control for the pumps. So if these pumps are on VFDs, we're going to be able to manage that. And we also have a dedicated alarm input, so we can take an alarm from a chiller. So the C1000 CHL is going to be good for up to 3 stages of chiller. Now remember, between the two hardwares, the C1000 and the M2000 is much more capable, but it does have a little bit higher price point. So depending on what you need on this can determine your hardware. But that C1000 will be good for 3 stages of chiller control, up to 2 pumps with lead lag and fail sequence in there. So we're going to add another stage of capability with the M2000, taking us up to 4 stages. We still get the 2 pumps with lead lag fail sequence, but we also have a modulating pressure control for the pumps now on that M2000. So both of these controllers will work for air-cooled and for water-cooled chillers. And like I said before, we have several safety sequences available for the water-cooled chillers in there. Let's take a quick look here at our I/O availability. So on the C1000, this is the lesser capable hardware. You can see coming up from the bottom, we have our control for our 2 pumps. Then we have outputs for up to 3 chillers. Inputs we have for pump proof, supply water temperature, return water temperature, and then we have, depending on if it's a water-cooled or air-cooled chiller, we can take either outside air or condenser water entering temp. So we know what temperature water is coming into our chiller. Okay. We can step up to the M2000. Here we have quite a bit more capability. All of our inputs are on the right-hand side there, working up from the bottom. We start off with outside air temp, supply water temp, return water temp. That is, of course, the chilled water side. And then we have individual pump proof for pump 1 and pump 2. Now we have separate inputs for condenser water entering and leaving, then our water pressure and our alarm input. Over on the left-hand side are all of our outputs, starting off with the first two, kind of the most important to the whole getting the situation moving is the pumps. So pump 1, pump 2, and then we have the first 3 stages of chiller. We get that 4th stage of chiller by using one of our analog outputs as with a digital logic. So keep in mind that where we say chiller 4 up there, that's analog output 3, and that is going to be providing 10 volts DC or 0 volts. It will be an on-off signal. So we've got our 2 VFDs for our pumps in there if we need to do pressure control. So let's take a look. Just going to jump over to focus here. And I am currently connected to my little test bench sitting right beside me. And I have a chiller controller that I have installed at address 13. So we're going to stick that guy right in this little gap that I have. So the chiller, as I mentioned before, is going to be a follower controller. So we're not going to find it in the masters, and it's not a zone controller. It's going to be down here in the other controllers where we would find the boiler and FlexIO and those others. So here's our chiller. We're going to give it address 13. And I'm just going to slide this icon right over in between 12 and 14. When we open this up, little double click there. Here is our water-cooled chiller. Okay, we can see our pumps running. This, of course, is not operating actual equipment. I didn't have a spare chiller laying around to put this on. So I've just put some switches and jumpers and a few resistors in to get these values to read on here. But we can see that pump 1 is our lead. It is trying to maintain 25 PSI, which it seems to be doing pretty well. There is our VFD output at 5.6 volts, and that's holding steady. And that's our chilled water. You can see how our water coming back is a lighter blue. Our water leaving is a darker blue, indicating that it's going to be colder. So this is, of course, going to be limited by the jumpers that I have installed and the resistors that I have installed right now. That's why we aren't seeing necessarily real world type values. We can see our current target set point. So I want 41 degrees. It thinks we're only getting 52. So we've got that chiller on trying to work things out. And we can see that our entering condenser water is cooler than our leaving condenser water. You can see how long this stage has been on. We've got a total runtime of 18 hours. That's about when I turned this controller on last night. So alarm contact state. So we don't have any alarm coming in from the chiller. Current outside air temperature, we are occupied. So just like set up before, if you're familiar with our boiler control, you see those little red boxes that are popping up around the various points. If I want to make a change to the pumps, just double click on that. And here's my pump sequence, main pump with backup pump. This is usually what we see. We do have the option for a single pump if we only have one and we don't need to worry about lead lag rotation or any of that, okay? So activation strategies on here, activate this main pump. So many times that's going to be temperature based. That could also be occupancy based. We can make it where either occupancy or temperature can cause it to start, or we can link these together, making that an and we have to be both warm outside and occupied before we're going to turn that pump on. Okay. Activate backup pump if main pump does not prove. So we're going to give it 10 seconds to get in gear and get going, after which we're going to rotate to our backup pump, and hopefully that will work for us. Okay, freeze protection sequences. So activate pump when outside temp is below. Okay, occasionally we see these systems not running any glycol, and so we need to have freeze protection. We just want to stir that water around. Don't let it be stagnant and have the opportunity to freeze. Okay. Occasionally what we will see is rather than CTs or some sort of individual pump proving, is we'll have a flow switch after the pumps, after the pipes come back together. And that can cause an issue when we're trying to do pump proving, except here we have our use same proof for both pumps, and that will be analog input 4. Okay, so if we look at our inputs here, input 4, proof of pump 1, is now going to become the pump proof for both pumps. Okay, so a new feature that we've added recently on the boilers and also in the FlexIO is pump 1 turn on. Okay, pump 1 failed. Well, let's go to try pump 2. Uh-oh, pump 2 also failed. Well, did they actually fail, or did just my proving method fail? And say if the paddle came off of the flow switch or something. Okay, well, if it's smaller circulator pumps or we have pressure control in the sequence, we can say allow both pumps to turn on. Okay, just turn both of these outputs on and hopefully I'm moving some water. But if we don't have VFDs involved, if there's no pressure control, and each one of these pumps, it can handle the full capacity of the system by itself, you know, perhaps we don't want to be checking that box, because if they were to both come on, we could maybe be blowing something up or doing some damage. Okay, and then we can also deactivate the pump when the alarm contact closes. Maybe we do want to do that, maybe we don't. Maybe we just want that chiller to shut down, but we want the pump to keep running. Same lead lag rotation sequences that you're already familiar with the boiler. No lead lag, self-explanatory. Pump 1 is pump 1 until it fails, and then we go to pump 2. Alternate pumps after each call, alternate pumps with a fixed runtime, and equal runtime. Reminder that equal runtime does require that call to satisfy before we can rotate pumps. So if you have a situation where that pump is going to turn on, say, late May, early June, and it's going to run all through the summer, never shutting off until sometime late September, you probably don't want to use this equal runtime because your pumps will never rotate. Just like on the boiler, where we can continue running pumps after we shut the boiler down to get the residual heat out into the loop, we can continue running the pump after the chiller shuts down to make sure that we get that chilled water out into the loop. Exercise your pump after every however many days you want. We can take that out to just over a month, but you probably want to exercise them more often than that. So continuing on here. That was our pumps. Let's take a look at our chiller. So we've got water-cooled chillers. We can have up to two-stage chillers, okay? Or I could have a single 4-stage chiller, but we don't seem to see that too terribly often. Usually it's single or 2-stage, but if we hit apply here, notice that our graphic is going to redraw to incorporate that second chiller. So we had to get a little creative on our piping there. So, but everything works for us. Standard minimum on and off time delays, so we make sure that we're not short cycling. We make sure we're not staging up, staging down too quickly. So we've got the interstage activation and deactivation delays. Again, when we're dealing with multiple chillers, we have the same lead lag sequence that the pumps have that you're already used to in ProLon. We've got the same choices available. Okay. Disable chiller when pump freeze protection is active. So again, that is back over here looking at the pumps. If this freeze protection is active because we have gotten cold outside, well, many times when it's cold outside, we don't need the chiller, but that maybe is not the case. Maybe this is some sort of a process or manufacturing or just otherwise high heat load, and we still need that chiller running. So we can just uncheck that box. Now we're getting into some of the safeties with the water-cooled side. So we can keep track of the condenser water as we're rejecting heat into that water. We have the ability to stage down the chiller if the leaving condenser water temperature goes above. Okay, so remember, like when we're dealing with a rooftop zone system, we have the ability to stage down the cooling if we don't have a whole bunch of zones calling or whatever. Well, if our cooling tower is having issues rejecting that heat, and this leaving condenser water temperature gets too high, we're going to be able to stage down. Now, hopefully we've maybe got a couple stages of chiller running at that point, and we can just back 1 or 2 stages off and still keep chilling as much as possible, but we want to protect that equipment. Here again, we have tried our best to word things as plainly in simple terms. Okay, here we're staging down. Here we're going to shut down the chiller immediately if the entering condenser water temperature is higher than, okay, we've got 100 degrees, or the leaving condenser water temperature is higher than 109. So we implemented a 3 strikes rule here. So you can choose if you want to continue with that. If we hit these limits 3 times within however long you decide is acceptable on that, we're just going to lock out. And it's going to require a controller reset or a power cycle to get that back on. So if you need to reset that, real easy, we can just head over here, config, device, and hit reset for the controller. Okay. Continuing on. So here's our set point mode fixed. This screen doesn't look too terribly dramatic because we're just holding a 41 degree set point with a 9 degree differential where we're going to stage up and stage down. So, but if we choose our reset function, well, reset source. What do I want to reset off of? The water coming back, the outside temperature, or here are those math functions. So I could use, say, math 1 to reset, and it's going to be looking at this math 1 over here in my rooftop cooling demand. This is installed as a follower device under that. And if we hit, that's actually not going to change, sorry. But this rooftop then that is maybe using that chilled water for its air, it can basically ask the chiller to turn the loop temperature down lower and lower as its demand increases higher and higher. So maybe we're doing just fine holding on one chiller at stage 1, but by the time we decrease that supply set point more, now we're going to need to stage up to get that water down colder. Okay, here's our pressure. Enable chiller water pressure control. So basically that is going to allow those analog outputs to try and control the pressure. And we have one analog output for each pump. Okay, Again, we've got pump 1, pump 2 on digital output 1 and digital output 2. Here we have VFD for pump 1, VFD for pump 2 on analog output 1 and analog output 2. Okay, and again, your pressure input is going to be on input 8 over here. There's your water pressure. So same setup as setting up pressure on anything else. Sensor type, you've got your choice of the 0 to 5, 1 to 5, 4 to 20. We've got a few oddball 0.5 to 4.5 sensors out there. And then 0 to 20 milliamp. Doesn't happen often, but it can happen. What does that pressure transducer signal represent? So here, the factory default is 0 to 50 PSI. We're trying to control to 25 PSI. So we do allow the integral here to get down into the seconds. Many times we want a faster acting integral with the pump control. And then your output signal, just like with the blower on a zone system rooftop. Are we doing 0 to 10, 2 to 10, 0 to 5? And we can actually set an absolute maximum. If this pump goes to 60 hertz, 10 volts, that's just way too fast, way too much pressure. I never want to see this go over 9.2. That's absolute maximum. Okay. Once we hit that, we will not put out more than 9.2 volts on that analog output. Okay. Standard calibration, anything input-wise that can be skewed a little bit, supply, return, entering and leaving condenser water, water pressure. These can all be adjusted as need be. Let's run back here and take a look. So we've looked at the water-cooled chiller, but if we change over to air-cooled here, a lot of this safety goes away because typically an air-cooled chiller is going to have all of its own integrated safeties because it's a package unit. It's not necessarily relying on other equipment to provide a suitable heat rejection source for it. So when we go back here, we've redrawn everything, kind of flipped it all over. But here's our two air-cooled chillers. But you will notice that we don't have those safeties pertaining to condenser water on this. So let's see, I think we had some questions pertaining to the chiller. Let me get my chat up here. Okay, what happens if both pumps do not prove? Okay, so if both pumps do not prove, we have the option to allow both pumps to turn on. Okay, so if this backup fails to prove, well, we've already tried the main, we've tried the backup, neither one proved. So we have that option, or we're just going to keep trying to run the backup on that until somebody takes a look at this. Now, hopefully, we have set up some sort of an alert that, well, if we don't get a pump proof within so long, it's going to send out an email alert. Okay, so moving on. Our rooftop and heat pump controllers now have a mode switch. So this is going to make it operate much more like a thermostat that you're used to. So there's a software switch that allows locking the operating mode of the system into heat, cool, auto, which is what ProLon normally does, or even off. There's a separate switch for the fan. So this is going to avoid our pitching back and forth between heating and cooling in the shoulder seasons. It will be ideal for residential systems, but you can see where there could be some efficiency-minded light commercial applications where they want to just make the decision that we are in cooling mode or we are in heating mode. So this function is going to be available on RTU, RTUS, HP, and HPS controllers. So heading back over to focus. I'm just going to close out of the chiller here, and let's go back to here. I have a single zone rooftop, and you'll see here is my mode set button. Okay. Of course, factory default is going to be auto for the fan, auto for the temperature control, which is basically going to leave the controller operating as you have known ProLon to function thus far. So now we have our system. We can choose, well, we are only going to have cool. We're going to let the fan continue according to its program, or perhaps I want it on. Again, be warned, fan off. If you set it to off, one of the things we require to operate is fan proof. So if you set that fan mode to off, you are not getting anything. You have just turned the whole unit off. This is not something you normally see on a regular thermostat. You have your choice of auto or on. Okay, so we'll just leave this in auto, but now by setting the system to cool, we have limited this to a heating demand will not be able to turn the heat source on. Even if we're cool in the morning, well, we'll just deal with being cold. Yes, we're generating heat demand, but we're not going to turn the heat on. We're going to take that cool as a jump on. It's going to be hot later today, and that's less air conditioning we have to do. Okay, so again, available for zone system and single zone rooftops and heat pumps. So we'll just put this back to auto. Okay, continuing on. The alerts and data logging. So this is a big change here. Used to be we could alert up to 100 lines and we could data log up to 50 points. So now as of 7.3, we are able to alert up to 200 lines, and data logging has been doubled as well up to 100 points. So we do have an updated interface for both the alerts and the data logging. Should be easier to keep track of how things are related and when you group alerts together. We have also added a new push notifications feature. So if you have the ProLon Focus application on your Android, your iPhone, tablet, whatever smart device, you can receive push notifications directly through the app rather than having to rely solely on email. We've also added the ability to send alerts just based on time. I'll show you that here. Rather than having to meet a certain function or failure, we've added the ability to send alerts based on time. Let's head back over to focus. We're gonna close that, go to our global view, head to our network controller because that's where all of this is located. We're going to go under config, and we'll just start here on the alert screen. Now this looks drastically different. If you remember the old alert screen, this is completely different in here. So I can start off, we've got everything grouped by device, or I can put them together in their group. So if I want to alert when my supply temperature is less than 35 degrees, I can get that as an email only alert. Same thing down here. All we need is an email address, and we'll handle it from there. So you can get push notifications only, in which case we don't care about the email. It's just going to go out to anyone who has the application installed, or we have the email and push notification, so you can get everything. Okay, this is a conditional alert. What is a conditional alert? It is when something has happened. Okay, So if my supply temp is less than 35 for at least 2 minutes, I'm going to get an alert. Okay, maybe that's not the greatest idea because it gets cold at night when we shut off in the wintertime, and that can trigger an alert anyway. So let's go find our, let's see, that was rooftop 10. So we're going to add again from rooftop 10. Okay, so now I can configure over here that my occupancy state, if it equals occupied, and then if we put these in the same group, there we go. Okay, and we can also view this as, well, group 1 consists of my occupancy state and my supply temp. So I can see all of the alerts that are included in group 1, and it will keep building as we add more and more groups. So in this situation, my supply temperature has to be below 35 for at least 2 minutes, and I have to be occupied for at least 2 minutes. So both of those have to be true before I'm going to get any kind of a notification. We could keep building on, and so now we can build this out as many conditions as you like, and we can have a total of 200 conditions in the alerts configuration. So data logging. Okay, it's still, it's been updated to have the appearance of the alert screen, but it's really going to be just as simple if I want to, again, log, say, my VC2000 PI zone temperature every 10 minutes. Okay, so we can add that in there. So we can also choose an offset every time my zone temperature changes by 0.2 degrees or however much change we want to see. Oh, you know what? I almost forgot. Let's jump back here to the alerts. We have had some instances where individuals need to keep a log. And so we can say, well, supply temperature, maybe we want to add, let's go back to zone rooftop. Okay, supply temp, but we're going to make this a periodic alert, and we'll say every 24 hours at 8 a.m. So every morning, I want to receive an alert that tells me what the supply temp on rooftop number 10 is. Okay, now that might not be the most useful, this particular situation, but there are certain situations, we've had surgery rooms, different medical facilities where they need to have like a daily log, and they would like to have this sent out to them automatically. There hopefully is nothing wrong. There should be no reason to be concerned, but we just need to receive an email about what is the current status, and whether this is supply temp, whether this is you know, a cooling stage, you know, is it running or is it not, a current demand based from a math function. Okay, so lots of different choices there, but you can send that periodically. It will send every 24 hours, and you can choose the time that it sends at. Okay, so that is our alerts and our data logging, how everything has been updated. Still have the little help hints down here as far as how long is it going to take to download your current log. Don't forget, once you have everything in here, you do need to start the logging. So I did make some changes here, so I don't have the ability to continue my previous log. I would have to start a new log. Okay, so I can tell it yes, and it's going to start recording that on the SD card now. Okay, So there's our alerts and data logging. This next one is more of an advanced feature. Many of you will not ever touch this, but there are a few of you that are going to get excited about having this available. So we have an adjustable integral drop-off. We're not going to get into the depths of proportional and integral and how that is calculated, but as the integral accrues, we keep driving our demand up, and eventually we reach a point where we have operated the equipment in such a manner that we have satisfied our demand. Well, once we satisfy the demand, there is no more proportional response, but there still is an integral that needs to decay, if you will. So this, for the most part, like I said, you're not going to be needing to use this. But slowing this down can be useful in zones which have a strong constant heating or cooling load, so that we don't just, oh, we're satisfied, shut everything off. We can keep a valve open partially, just making sure that we're not swinging too far. Just for quick reference, that level 4 there at 0.8% per second of the integral, that is how ProLon has worked up until now. So we can speed it up a little bit and we can slow it way down if we need to. But for the most part, all of you guys, you're going to leave it on level 4, the factory default, just because that's what you're going to need. We have some new features in the Focus software. The M2000 controllers, we get confusion a little bit on this. So an M2000 controller, when it receives a schedule from the NC 2000, is going to have their internal clock time hidden. And what we're talking about here is, if we go find an M2000, let's go to this zone rooftop here, and we see that we have a time clock listed up at the top. Well, this time clock is the local time clock in this zoning rooftop. If this zoning rooftop is receiving a schedule command from the NC 2000, we really don't care what time this clock is. And having that clock be incorrect at times can raise questions for people unnecessarily. So think, oh, well, the time's wrong. Maybe that's the problem. Well, the time had no effect to it. So if I go into my network control and let's go and distribute a schedule to RTU 10, we're just going to have it follow schedule 1, since I've already got that set up. So now RTU 10 that we just looked at is receiving a schedule from the NC 2000. And when I open this up, notice my time clock has now disappeared because it doesn't affect anything. So just like if I go look at my schedule over here, everything is grayed out. I can't change anything because the schedule is being controlled by the network controller. Okay, so that's a handy little thing. We also have a new safety that's been added. The reprogram tool has a safety prevent installing an incompatible software into a controller. So that would be like trying to put an M2000 RTU program into a C1000 piece of hardware. The software is not compatible between the different hardwares. So if I were to go in here to my chiller, this is an M2000, and if I wanted to go and reprogram, I'm going to go browse in my files here and say if I want to change this chiller to a C1000, incompatible. Okay, this hex file is meant for a C1000, but my device is an M2000. So we had a couple unfortunate incidents that you know, necessity is the driver there. We had some situations that had to be corrected. So this will just keep those situations from occurring in the future. So continuing on, we have the new Android application. So heads up, guys, this is a complete rewrite. It has been rewritten from the ground up, totally redesigned. What we have strived for is that the Android application will match the Apple application as much as possible. Of course, there are some programming and code differences there that don't allow them to be exactly the same. But as much as we can, we tried to make them the same so that if one time you're accessing using an Apple device, another time you're accessing using an Android device, it is as close to the same experience as possible. Okay, so as you're aware, the panels, the NC2000 panels that have the tablet on them, they run the Android application. Okay, so those will be coming out with a new application installed, but we can upgrade older panels. Already installed panels may be updated to the new version using the Play Store, but there is one thing that we need to check on this here. So the old version of the application required a minimum of Android 4.1 Jelly Bean. Okay, the new application that we just released today requires a minimum of Android 5.0 Lollipop. The original tablets that came out on the NC2000 panels were shipped with Android 4.4.2. So an update of the operating system may be required first. If you need assistance in doing this, please give us a call at on the tech support line, and we'll be able to help you out with that. Let me just show you real quick what this looks like. So what I have here is just a little emulator that makes my computer able to run Android applications. It currently thinks it is a phone. So it's going to be operating as a small screen device. So we'll go here to, actually first we're going to go over to focus so I can disconnect because we can only have one connection at a time. I'm going to open up my test bench. Okay, so you can already see that this is completely different. If you've interacted with the Android application before, it doesn't look anything like what it used to. Okay, I'm going to go into my test bench. Each time the screen changes, that's a click or a tap. So we're currently offline. Come up here into the upper right corner, and I can tap for what do I want to do, what type of connection. Well, I'm just going to do a direct connection locally here through the network. So we're connected. We see stuff starting to come online. If I need to do an update, I can refresh all. So this is going to go out and get all of the information from the controllers and bring those in for me to have current data. So it'll just make its way around, refreshing everything. So you can see the plus down here in the lower right if we need to add a controller, if we're configuring or building this network. Let's just go into this zone rooftop. This is that address 10 that we've been looking at. Graphics are going to be quite different. And again, the reason why I have to scroll on this is this thinks it is a small screen device, so it's operating like a phone-sized screen. So we can see our current math functions. You see how I have named those. If I wish to rename them, we can just tap there and give it whatever friendly name we need. Come down here, we see our current status. These are grayed out. We can see what's going on, but if I tap on this, I can't make any changes. And then down here at the bottom, we have our overrides. Okay, so if I needed to override my fan, so we can override that. And basically the value there is going to be on or off. Okay, so we'll step back here. configuring a controller in this. So you see up here in the upper right corner, I've got my little sliders. Okay, well, that's how do we want to position things for this to operate. So I'm going to click there for my configuration. We'll find out my device type, software version, and now I can get into, here's my temperature setup, my set points, heating minimum, maximum, all that. Take a step back, and we can scroll down and get my damper. Okay, well, this is a pressure dependent. We need to reverse the direction clockwise. There we go. Once we get everything set in this, okay, all of this is accessible as before. So we can back out, and now we can hit save. It has written to it, and my actuator is now driving to the other position. Okay, so that concludes what we had to show you for the 7.3 release. I do just want to make sure that you have our information available. So ProLon contact information, 1-877-9-ProLon. That's 977-6566. You can also reach out via email, info@proloncontrols.com, or you can contact me directly, christopher.lyon@proloncontrols.com. So we'd be happy if you have any more specific questions or concerns, or you want to start looking at projects that could involve some of these features, or you just couldn't get your head around what was going on with something, would be happy to talk to you. Feel free to give us a call. Did we have any other questions here? Let me get my chat back open. Does not look like we have any other questions. So with that, I guess we will go ahead and conclude. So thank you everyone for taking time to see what we have to offer, and look forward to the next release, whatever that may hold. You know it will be coming because we're ProLon, and we're always looking to improve and add features. If you have input that you would like to give, things that you would like to see in ProLon controls, please don't hesitate to bring that up to us when we're on the phone with you or in an email. We're always welcome to suggestions. So again, my name is Chris Lyon, technical sales for ProLon Controls. Thank you for your time today. Appreciate it very much. And we will see you next time.